everyone. In this video, we're going to look at some of the applications of trig derivatives. So basically anything we could do, curve sketching, applied maximum and minimum problems, related rates, those sorts of things. If we have trigonometric functions, we can do those same applications. So let's look at a maximization problem. So we have a vertex of a triangle, which is at the center of a circle with radius r. So those would be these two lengths. The other two vertices are on the circumference of the circle. For what central angle theta is the area of the triangle a maximum, and what is the maximum area? Obviously, that's going to have to be given in terms of r because we don't have any specific dimensions here. Given that I'm looking at maximizing the area for a particular angle, I want a function for area as a function of the angle. So the area of a triangle is 1/2 times two lengths which are adjacent to an angle, and both of these are r, so r squared, times the sine of that angle. Or just expressed more simply, r squared over 2 sine theta. Now remember here that r is a constant, so I don't need to worry about deriving it implicitly when I'm deriving this function. So to maximize this, I'm going to derive it. The derivative of the cosine, of the sine function is cosine. So r squared over 2 is my coefficient times the cosine of theta. So I'm going to have maximums wherever cosine of theta equals 0. Now I do know that because this angle is inside of a triangle, the angle has to be between 0 and pi. So I really only have one maximum in that interval. The cosine of theta equals 0 when theta equals pi over 2. So I'm going to think about where that would be minimum maximum. So if I think about from pi over 2, and again, remembering that I have hard stops here at 0 and pi because those are contextual limits on this problem. If I have an angle between, now so r squared over 2 is always going to be positive. First off, because the radius is positive, but even if it wasn't, if I squared it, it would become positive. So the cosine of a number that is less than pi over 2, so an acute angle, is positive, and the cosine of an obtuse angle between pi over 2 and pi is negative. So the function is going to be increasing and then decreasing. So in other words, this is in fact a maximum. I have a maximum when pi over 2. So the first part of this question says what angle. So max at theta equals pi over 2 is the first part of this answer. What is the maximum area? Well, the maximum area is therefore going to be 1/2 times whatever the radius squared is, times the sine of pi over 2. The sine of pi over 2 is 1. So the maximum area is just r squared over 2. That is the maximum area we can obtain. Another type of application would be a related rates question. So we have the light on top of a police car is rotating at 2 revolutions per second. So that's actually giving me delta theta. So the change in an angle, revolutions are about angle. So theta dt is 2 revolutions, which is 4 pi, because each revolution is 2 pi radians. So 4 pi radians per second. And because radian is unitless, you can actually write radians per second, but you don't have to. All right, let's try and get a diagram here. The car is 9.25 meters away from a wall. So we have a wall. We have a car. That car is 9.25 meters away from that wall. And those are always measured directly, so that must be a perpendicular angle. At what speed is the light moving along the wall when it passes the point on the wall closest to the car? So essentially, let's imagine the light is kind of moving this way. So there'd be a series of triangles here where the light is rotating, which means that this is where theta is being measured, the angle at the car where the light is rotating. I want to know if I call this x, dx dt, at the moment that it is at the point closest, so at the moment when x equals 0. That's what we're looking for. So I can look at a relationship here between theta and x. So tan theta equals x over 9.25, which means that I can now derive with respect to time. So the derivative of tangent is secant squared of theta times d theta dt equals 1 over 9.25 times dx dt. As it turns out, the actual x value isn't going to matter here, but I do need to be able to calculate secant of theta when x equals 0. Well, when x equals 0, theta equals 0. So when x equals 0, theta equals 0, which means that the secant of theta, remember that secant is 1 over cosine. So the cosine of 0 is 1, 1 over that is 1, that squared is 1. So we get secant squared theta, 1, times d theta dt, which we know is 4 pi, times 9.25, is equal to dx over dt at that moment when x equals 0. So if I just multiply all these things together, I end up with either, if you want to express it as an exact value, you can call it 37 pi. And this is going to be meters per second because that distance is being measured in meters, or approximately 116 meters per second. And that would be the answer to this question.